Start ArcMap. In the Getting Started window, click on the Templates North American entry. Scroll down and find the ANSI letter Portrait template and click to highlight it. Before going on, click on the button to set the default geodatabase. Navigate up to the Oregon folder, open it, and select the Oregon Data Geodatabase. Click Add. Finish OK to complete opening the map. Choose Save. Save it in the Map Documents folder, and remember to save periodically as you work. Click on the Add Data button. Find the Default Geodatabase button on the toolbar and click it to go directly to the default geodatabase, Oregon data. Add the counties, hold down the Control key and click on Volcanoes, and click Add to add them both to the map. Click on the Add Data button. Double-click the Transportation Feature Dataset to open it. Click on the airports, hold down the Control key and click on the highways. Click Add to add them to the map. Click Add Data again. Click the up arrow to get out of the Transportation Feature Dataset. Double-click in the Water Feature Dataset to open it, and click on the rivers. Click Add to add them to the map. In the Table of Contents, click twice slowly on the layer's data frame name and type in the new name Geography. Click Enter to complete changing the name. Click on the Data View button to make sure that you are in Data View, seeing the map but not the layout page. Click on the airport symbol to open the symbol selector. Click on the Style References button to view the list of additional styles that could be added to the symbol selector, but cancel without selecting any at this time. Click on the Edit Symbol button and take a moment to examine the symbol editing window. Explore it for a while if you wish, but click Cancel so that you exit without incorporating any changes to the symbol. Still in the Symbol Selector window, click in the search box and type Airplane. Click the Search button. It will find different airplane symbols from different styles. Choose the airplane symbol from the Esri style. Increase its size to 25 points and set the angle to -45 degrees. Click OK to finish setting the symbol. Right-click the airports layer and choose Copy. Right-click the Geography data frame name and choose Paste Layers. In this new layer, click on the airplane symbol to open the symbol selector. Search for the airplane symbol type again. And this time, choose this cartoon symbol and click OK. Turn them each off individually to compare how they look. Notice that the simple symbol is actually much easier to see than the cartoon symbol. Right-click the airports with the cartoon symbol and choose Remove. Right-click on the symbol for counties and choose More Colors at the bottom. If necessary, change the color model from RGB to HSV. Use the sliders to vary the hue, saturation, and value for the colors until you understand how these effects are produced. When you're done, click Cancel. Right-click on the symbol for counties and change the color to a light yellow. Right-click on the line symbol for rivers and change the color to a deep blue. The rivers seem to be cluttering the map at this scale, so let's put a scale range on them. Right-click the rivers layer and choose Properties. Click on the General tab. Fill the button for Don't Show Layer when zoomed out and set Out Beyond to 1 to 3 million. Click OK. Click twice slowly on the Airports layer and capitalize the first letter. Click Enter to enter the new name. Double-click the Airports layer to open its properties and click on the Labels tab. Check the box to label features in this layer and leave it set to label all features the same way. Make sure that the label field is set to name. For the font, choose Arial 9-point and make it bold. Click Apply to make the changes, but keep the window open. Move it aside if necessary to see the labels. In the Label Properties window, click on the Symbol button. Notice the different style presets available, but don't choose any right now. Instead, click the Edit Symbol button. You can do very detailed editing here, but for now we just want to set a mask. Click on the Mask tab. Choose Halo, leave the size at 2-point, and click OK, and then OK to close the symbol window, and Apply to enact the change. In the Label Properties window, click on the Placement Properties button. Make sure that the Placement tab is clicked. Examine the diagram that shows the placement priority around the point. Click Change Location to examine some of the other options, but don't choose one at this time. Click Cancel. Click OK to close the layer properties. We are finished with the airports. Click on the Rivers layer twice slowly and give it a capital letter. Click Enter. Double-click Rivers to open its properties. Click on the Labels tab if necessary. Check the box to label the features and make sure that the label field is set to name. Make the symbol Arial 8-point. Change the color to dark blue and make it italic. Click OK. The Rivers layer has a scale range, so to see them, set the map scale to 1 to 3 million. Double-click Rivers again to open its properties. On the Labels tab, click the Scale Range button. Change the settings to Don't Show the Labels when zoomed out beyond 1 to 1 million. Click OK, and then click OK. Set the map scale to 1 to 1 million. Double-click Rivers again to open its properties. Click on the Placement Properties button. Choose the Curved Orientation button. Check the boxes to position the labels above or below the line. Examine the other settings but leave them alone for now. Click OK to finish setting the placement options, and then OK to finish modifying the labels. Examine the labels, and then use the Full Extent button to zoom to all of Oregon. Click twice slowly on the Highways layer and capitalize the first letter. Click Enter. Click on the Highway symbol and give it a thick brown colored symbol in the symbol selector. Click OK. Double-click the Highways to open its label properties. Click on the Labels tab, turn on the labels, and make sure that the label field is set to Highway symbol. Click on the Symbol button. In the symbol selector, scroll down and choose the U.S. Route Highway symbol. Click OK. Click on the Scale Range button in the Layer Properties window. Click Don't Show the Labels when zoomed out beyond and set the scale to 1 to 1 million. Click OK. Then click on the Placement Properties tab. Choose the horizontal orientation. Click OK, and then OK again. Use the scale box to zoom to 1 to 1 million to see the labels. Then return to the full extent of the map. Click twice slowly on the county's name and capitalize the first letter. Click Enter. Double-click the counties to open its properties. Click on the Labels tab. Turn on Label Features for this layer. Make sure the label field is set to Name. The font can be Arial 8-point, but make it bold. Click on Symbol, and then on Edit Symbol. Click on the Mask tab. Choose Halo, and leave the size set to 2 points. Click OK, and OK, and then OK once more. Click twice slowly on the Volcanoes layer and capitalize the first letter. Click Enter. Right-click the Volcanoes layer and choose Open Attribute Table. Examine the fields. Close the table window. Double-click Volcanoes to open its properties and click on the Symbology tab. Click on the Quantities text on the left for the map type and choose Graduated Colors. Set the value field to Elevation. A set of classes appears with the default to 5 classes and the Jenks Natural Breaks classification. Set the color ramp and click OK. Double-click on the Volcanoes layer to open its properties. Under the color ramp setting, click on this symbol heading to reveal a menu. Choose Properties for all symbols. Choose the Triangle 2 symbol and click OK. Change the color ramp to a monochromatic one, which will show a sense of increase better. Click OK. The map is looking really cluttered, so turn off the Airports layer. Right-click the Counties layer and choose Label Features to turn the labels off. Double-click the Volcanoes to open its symbol properties again. Change the Quantities map type from Graduated Colors to Graduated Symbols. Keep the value field set to Elevation. Circles are the default symbols, but triangles would make more sense. Click on the Template button to change the symbol. Use the Triangle 2 symbol again and set its color to a reddish brown. Click OK. Change the smallest symbol size to 6 points and the largest size to 20 points. Change the number of classes to 4 and click OK. Click twice slowly on the Volcanoes layer name and rename it Volcano Elevation. Click Enter. Double-click Volcano Elevation to open its properties. Click on the Labels heading to the left of the Template button. Choose Format Labels. Under Rounding, fill the button for number of significant digits and set the number to 2. Click OK and OK. Click twice slowly on the elevation text underneath Volcano Elevation and change it to meters. Press Enter. Right-click on the Volcano Elevation layer and choose Copy. Right-click the geography data frame name and choose Paste Layers. Give the new volcano elevation layer a different name. Call it Volcano Type. Press Enter. Drag it below the airports layer if necessary. Double-click the Volcano Type layer to open its properties. Click on the Symbology tab. Click Categories to change the map type and select Unique Values. Change the value field to Type and click the Add All Values button. It will not show the categories until you do. Notice the All Other Values symbol at the top. Uncheck it because it is not being used. Click on the top Shield Volcano symbol, then hold down the Shift key and click on the second one. Right-click one of the selected ones and choose Group Values. Click under the label heading and replace the double layer with simply Shield Volcano. Press Enter. Click down below in the empty space to clear the selection on the rows. Click on the symbol heading and choose Properties for all symbols. Set the symbol to Triangle 2 and click OK. Change the color ramp to one with dark, bold colors that will show up well. Examine the window and then click OK. Turn off the volcano elevation layer. Scroll down to find the Highways layer and right-click it and choose Open Attribute Table. Examine in particular the Highway Type field. Close the Attribute Table. Double-click the Highways layer to open its properties. Make sure that you're on the Symbology tab. Choose the Categories heading for the map type and select the Unique Values map. Set the value field to Highway Type and click Add All Values. Click the Count heading above the categories to force it to count the number of features in each category. Notice the lone H values and 58 unlabeled roads. Click on the row containing the H value and choose Remove. Also remove the class with the unlabeled roads. Click on the U under the label heading to highlight it and type in U.S. Highways for a more descriptive label. Click on the S and type in State Highways. Finally, click on the I label and retype it as Interstates. Click on the All Other Values label and change it to Unclassified. Then click on the U.S. Highways row and click on the up arrow to move it underneath the Interstates. Double-click the symbol for the Interstates to open the symbol selector. Choose the Expressway symbol and click OK. Double-click the symbol for the U.S. Highways. Select the Major Road symbol and change the color to a dark green. Click OK. Double-click the road for the State Highways. Choose the Major Road symbol and set the color to a light brown. Click OK. Then click OK to complete the map. Double-click on the Counties layer to open its properties and click on the Symbology tab. Choose Quantities and Graduated Colors for the map type. For the value field, select Pop 2010. Because population is usually normalized, click in the normalization box, scroll down, and select the square mile field. Make sure the color ramp is monochromatic, such as light to dark orange. Click on the label heading above the classes and choose Format Labels. Give them 2 significant digits, and check the box to show thousands separators. Click OK, and then OK again to view the map. Click twice slowly on the county's layer name and change it to population density. Click Enter. Right-click on the population density layer and choose Copy. Right-click on the geography data frame name and choose Paste Layers. The new one will be placed above the old one. Click the new layer name twice slowly and rename it Median Age. Press Enter. Double-click Median Age to open its properties. Click on Quantities, Graduated Colors. Change the value field to Median Age. Change the normalization to None. Click on the label heading and choose Format Labels. Change it to the number of significant digits and set the number to 2. Click OK and OK. Double-click the Median Age layer to open its properties. In the Symbology tab, click on the Classify button. Take a moment to examine the histogram, noting that these data are fairly uniformly distributed. Change the classification method to Defined Interval. If you get an error, just click OK and continue. It's just a bug. Set the interval size to 5. Click OK and OK again. Examine the new data ranges. Click on the Add Data button. Move back up to the main Oregon Data Geodatabase and click on Cities to select it. Click Add. Double-click the Cities layer to open its properties and choose the Quantities Graduated Symbols map type. Set the value field to Pop 2007. Click on the Classify button. Change the number of classes to 3 and click OK. Click the Template button and set the color to a light one. The symbols show up better that way when they overlap. Click OK. Choose Label, Format Labels. Set it to number of significant digits and change it to 3. Check the box to show thousands separators. Click OK and OK again to view the map. Find the volcano elevation layer. Right-click it and choose Copy. Right-click the geography data frame name and choose Paste Layers. Name the new layer by clicking on it twice slowly and call it Known Eruptions. Press Enter. Turn it on and double-click it to open its symbol properties. Keep the graduated symbols map type, but change the value field to Known Eruptions. Examine the class values, and then click the Classify button. Click on the Exclusion button. It will open a window to build a query. Enter the query Known Eruptions less than 0 in the lower panel. Verify it, and then click OK, and then OK to use the expression. You may not see a difference yet because of a bug in the software. Click OK, and OK to close both of the windows. Double-click Known Eruptions again to look at the symbol properties. Click on the Classify button. Notice that the negative values are now gone from the statistics and the histogram. Set the classification method to defined interval and set the interval size to 3. Click OK and then OK again to finish symbolizing the layer. Turn off the other volcano layer so you can see it better. Right-click the Known Eruptions layer and choose Copy. Right-click the Geography data frame name and choose Paste Layers. Double-click the new layer to open its symbol properties. Set the map type to proportional symbols and set the value field to Known Eruptions. Click on the Min Value button. Select Triangle 2 and change its size to 10 points. Use a light color so that it shows up well. And click OK. Check that the largest size is not too big, and click OK again to use the symbols. Click the minus sign next to the Geography data frame to collapse its contents. Click on the Layout View button to switch to Layout View. Choose Insert Data Frame from the main menu bar. Arrange the first data frame at the top of the page and put the second one on the bottom half of the page. Click the name of the new data frame slowly twice and change its name to Rasters. Press Enter. Activate the Rasters data frame by right-clicking its name and choosing Activate. Click the Add Data button. Find the GTOPO 1 kilometer raster in the Oregon Data Geodatabase. Select it and choose Add. Click the button to return to Data View. You should see the raster. Double-click the GTOPO layer to open its properties and click on the General tab. Note that the elevations are in meters. Click on the Source tab and examine the properties of the raster. Examine the cell size and scroll down and examine the spatial reference or coordinate system. Click on the Symbology tab and examine its settings. Close the Properties window. Click on the Identify tool and click on the raster to view the values for a pixel. The stretched value is the symbol number from 0 to 255. The pixel value is the elevation in meters. Count tells you how many pixels have that value. Click on More Pixels of the raster, choosing black, gray, and white ones. Compare the values for each one. When you're finished, close the Identify window. Double-click the GTOPO raster to open its properties. Click on the Symbology tab. It's currently using a standard deviation stretch. Move the Properties windows aside so that the map can be seen. Change the stretch type from standard deviations to none and click Apply. Change the stretch type back to standard deviations and click Apply again. In the Symbology window, try experimenting with different color ramps. Click Apply after each one. Finish by selecting this one and click OK. Click twice slowly on the GTOPO layer and rename it Elevation Stretched. Press Enter. Right-click the stretched layer and choose Copy. Right-click the raster's data frame and choose Paste Layers. Click twice slowly on the new layer and rename it Elevation Classified. Press Enter. Double-click the Elevation Classified layer to open its properties and click on the Symbology tab. Change the display method to Classified. Find the same color ramp that you used before. Set the number of classes to 10 and click OK. Click on the Identify tool. Click to examine some of the different pixel values and class values. Close the Identify window when you're finished. Double-click Elevation Classified to open the symbol properties. Click on the Classify button. Change the classification method to Defined Interval and set the interval to 200 meters. Click OK. But first notice the histogram and how few values there are in the upper classes. Click OK. And then OK again to use the classification. Notice that many of the higher values are now missing. Click on the Add Data button and add the G-Topo Shade raster from the Oregon Data Geodatabase. Click on the Elevation Classified layer and drag it above the Topo Shade layer. Double-click Elevation Classify to open its properties. Click on the Display tab and set the transparency to 50%. Click OK. Click the minus signs to collapse the 3 rasters you've classified so far. Click on the Add Data button and add the Slope Class raster from the Oregon Data Geodatabase. Click Add. It shows areas of low, medium, and high slope. Double-click the Slope Class layer to open its properties and click on the Symbology tab. If the value field defaulted to the class field, change it to the value field. Notice that a unique values map type was initially chosen. This choice is fine, but for ordinal data, a monochromatic color ramp will show the data better. Click on the Color Scheme button and find a monochromatic ramp. Click Apply. Experiment with different ones until you find one that you like. Then click OK. Click the Add Data button. Choose the Land Cover raster from the Oregon Data Geodatabase and click Add. Right-click the Land Cover layer and choose Open Attribute Table. The value field is the number stored in the raster, and the display and other codes indicate the land cover. Close the table window. Double-click Land Cover to open its symbol properties. Scroll down and examine the colors and values. This raster defaulted to the color map style, which assigns a different color to each number in the list, based on a file. Close the Properties window and click on the Identify tool. Notice the color index, which is the value of the raster, and then the color mixture that's being applied to that number. Further down, you'll see the cover type. Click on different symbols to get an idea of the kinds of cover types and symbols in this dataset. When you are done, close the Identify window. Double-click the Land Cover raster to open its properties. Change the display method to unique values. Change the value field to Tab name. Click OK. Click on the minus sign to collapse the legend for the land cover layer. Click and drag the DTopoShowed layer just below the land cover layer in the table of contents. Double-click the land cover layer to open its properties. Click on the Display tab and set the transparency to 50%. Click OK. Click the check boxes to turn off all the rasters in the Rasters data frame. Click the Add Data button. Navigate up to the Oregon folder and choose the L7 Landsat image. Click Add. Click Close to ignore the Geographic Coordinate Systems warning. Click twice slowly on the image layer name and rename it Landsat. Click Enter. Right-click the Landsat layer in the table of contents and choose Zoom to Layer. Double-click the Landsat layer to open its properties and click on the Symbology tab. Click Stretched for the image type and select Band 1 as the band to display. Keep the default standard deviation stretch and leave the other settings. Click Apply and move the Properties window aside to examine the image. In the Layer Properties window, change the band to Band 4. Click Apply and examine the image that way. Examine each of the other bands in turn, noticing the different reflectances for each one. On the Symbology tab, change the map type to RGB Composite. Choose Band 3 for the red channel, Band 2 for the green channel, and Band 1 for the blue channel. Click Apply and examine the map. This should be a true color image. You can experiment with different stretches, clicking Apply after each one. Leave it on the one that you like best. In the symbol properties, change the red channel to Band 4, the green channel to Band 3, and the blue channel to Band 1. Click OK. Turn off the Landsat layer. Click the Add Data drop-down button and choose Add Data from ArcGIS Online. Type Landsat in the search box and click Search. Find the worldwide Landsat GLS Mosaic. It's an image service. Click Add to add it to the map. With worldwide images, the statistics used to calculate the stretches often don't work well in smaller areas. You can use statistics from the local window to get better results. Double-click the Worldwide Landsat to open its properties. Under Stretch Statistics, choose from the current display extent. Choose a standard deviation stretch and click OK. This looks much better. Click on the Zoom Out tool and draw a small box to zoom out and see more of the image. Continue experimenting with displaying this image if you have time. Pan or zoom to other parts of the country to see how it looks. Remember, it's an internet service and may take a little bit of time to refresh.